Yo, what's up, ladies and gentlemen? This is Papa Bale, and we're looking at an 8-inch rotor with 12 magnet nodes on it. So each node has a 100-pound magnet with 3 M.P.H magnets on top of it. Now I have it. Somehow this transformer got fried. Somebody almost started a fire. I'm hoping it wasn't me. It might have been me. That would have been terrible. But now I have it hooked directly into the power supply. And we're going to crank up the juice all the way to 25 volts. Now there's no amps going through this right now. Just 25 volts, which you can like break down, but it's really, there's nothing. I think the amp output might be broken. So yeah, that gets going pretty quick. I'm going to try and get another transformer up and running so that we can like see what's really going on here. That's whipping along quite a good pace, but I was expecting more with the four-filar coils all pointing in the right direction. I was just expecting it to whip. But each one of these big ones has a core in it, which may offset the four-filars, which would then have the main force be pushing from here and from there. And every once in a while, these ones will hit. But I think that's a sweet spot with the reed switch. I think that's pretty good for 25 volts. It's pretty decent speed. Yeah, I don't have a multimeter hooked up or anything else hooked up right now. I just have the rotor hooked up, and it's a little off balance slightly, but it's pretty good. Yeah, it's just whipping right along. All right, I'm gonna cut it, turn it all the way off, and we're gonna see how long it takes to slow down. So when it gets down to about 25, it starts going real slow because you get this feedback into the power supply. So it stays lit a little while longer. Now what I'm thinking about doing is putting ones with cores in them here and here instead of what we have. Well, that's that. What was I thinking? Well, I did want to show you that. Now, see, I spun it with my finger and it starts going up. That's probably going to be its max, 20. Wow, it's right at 20. And since I spun it with my finger, all that 0.2 of a volt is being, that's an output meter that's on the power supply. It's an output meter, so that's actually being fed back into the system, which I'm sure is making this spin longer than it usually would for, even though it's less than a volt. See, now I turned it all the way up. This is 25. But I'm going to turn it down to 8. I get 10. Yeah, I think that's good for 10. Will it slow down more? Maybe. But it's good. I think it's good to have more control sometimes than to just, pull the throttle pin all the way out. Just when you turn it on, you're going 30 like right away. That's what a transformer is like with one of these. You just get going real fast right away. All right, we're going to drop it to 8. 832. It's weird the way I came in here and everything was kind of on. After, I don't remember turning it on. I don't know. It sounded like my world just blew up again. That's what it sounded like to me. That's what it feels like. This is 8.32. Drop it to 594. Yeah, well, I don't know. I don't think I really crossed any boundaries. I might be totally wrong about that, though. 5.94, and it might stop now. Yep. $5.94. $6.63. Okay, you can argue that. All right, looks like it's going to be about 8 volts. This is minimum. So 8.43. Might be able to get it down to 7.5. Excellent. 7.62. It's like, no, man. We're not talking microvolts. That was going to be 8 plus. It's going to be 8 plus for the pulse motor here. Yeah, we're going to make it with the core elements over here. Over here. Switch it up. Switch it up. Switch it up.